Hey, what's up folks? We are back again with another problem. Today we need to divide two integers without using multiplication, division or the mod operator, and we just need to return the quotient and the integer part of that quotient, and we need to neglect all the decimal part. And we also have a condition that if we ever encounter overflow, that is a number that can't be stored in a 32-bit signed integer range of Java or any other programming language. That I'm not familiar with how other languages integer types in type works, but I know in Java that it's 32-bit, and the range is from -2 raised to the power minus 2 raised to the power 31 to 2 raised to the power 31 minus 1. So what we need to do is, if we encounter any kind of overflow, we need to return this value, that is the upper range. Let's just first think of this condition when we need to divide two numbers, right? So when is the condition will occur that it won't be able to we won't be able to store it in a -32-bit range if we are given our numbers less than this. So the only condition when this can occur is when we are given this number and we need to divide it by -1, because dividing reduces the number, doesn't increase the number, unless the number is already greater than the maximum range that can be stored. It's just on the negative part, and if we make it positive, it would be one more than the number that can be stored. So let's just take care of this condition, then we'll see how can we divide two numbers without multiplying. First I am going to write that dividend, if my dividend is equals to integer dot min value, because it's 2 raised to the power 31 in negative form there, and my divisor must be equal to -1. If that happens, I will have a positive 2 raised to the power 31, and that is out of range, so I need to return sorry for that. So I need to return my maximum possible value for that integer. Done. Now let's think about the division part. How do we actually divide 10 by 3? Here is an example of dividing 10 by 3, which gives us 3.333, and which is actually 3 because we remove all the decimal parts. Again, how do we do that? Is first we take away 3 from 10. Let's do this. We have a 10, we take away 3 from it. Well done. Now what we have 7. Let's take away 3 from 7 again. So we have a 7, we take away 3. What do we have is 4. Let's take away 3 from this 4 also. We have a 1. Let's take away 3 from this 1 also. Oops, we cannot take away this 3 away from this 1 because it's less than this 3. So we need to take care of one condition, that dividend, I'll write it, capital D minus D should be greater than 0, greater than or equal to 0, because we can take away 3 from 3, but we cannot take away 3 from 2, 1 or 0. So this is one way of doing it. And how do we know what the quotient is? It's 1 plus 2 plus 1 plus 1 plus 1 thrice, so 3 is the answer. Let's think of another way, a much better way, which is a logarithmic way. We were taking a logarithmic way. Yeah, what we have to do now is, instead of taking away 3 from it, let's see what's the maximum value that we can take away from this. We can't multiply it because that's not allowed, so we can only add it, maybe to itself. Let's do this. We first make something called a counter. Let's start it with 0, because now we need to count the steps. I'll explain you how. So let's take away 3 from this 10 once. Okay, we can. Let's mark it step 1 successful. Let's take away this twice. So we multiply this 3 twice, that is, we add a 3 to itself. That becomes a 6. We can take away that easily. Now we have the third value, which is 6 plus 6, which gives us 12. We can't do that, so let's remove it. This is twice. We store it, it's twice there. Now Again, what we have is the maximum value is 6 in the multiple of 2, that is 3 into 2 into 2, how much that can be possible, because we had 3 to itself, that becomes 6, we had 6 to itself, that becomes 12, we had 12 to itself, that becomes 24, and so on. So the maximum value that we can take away from this 10 is this 6, so let's do that, and it becomes a 4. Now after that, let's check if we can take away this 3 from this 4 once. Yes, we can. Again, let's try to take away this 6 from this 4. Can we do that? No, we cannot. So this is just 1, and we increment it, and hence there we have our value. So this is a much better way. You see, although there are 3 steps in here and 3 steps in here, but as the number grows larger, these steps decrease significantly. So we have taken care of the corner case. Let's take care of our solution now. So I'll create an int result that would be equal to, let's create a function called get count. I'll give it my dividend followed by my divisor. Done. Now what I want is, why is this happening? Let's check if it's indented in a proper way. Yeah, it is. Okay. Okay, I feel like I have invaded something. I should remove this. Now it's fine. Yeah. So indentation can help you see your mistakes. Again, where were we? Hey, wait a second, is it recording? Yes, it is. I'm so sorry, I had to check that in between. Now what we need to do is, we need to return something. So we return our result, but there's a flaw in this. Why is there a flaw? Is because you take 3 cases. 10 divided by 3. Okay, cool. Then again, one another case is minus 10 divided by 3. Okay, super cool. Then is 10 divided by minus 3. Okay. Then we have a minus 10 divided by minus 3. So you see these cases, this should return a positive 3, this should return a minus 3. So should this also return a minus 3? Yep. And this should return a positive 3. But using our algorithm, we cannot differentiate between positive numbers and negative numbers, so we only take positive numbers. I haven't done that. Let's do that. So we need the absolute value, so I'll call it int dividend. Let's call it absolute value is equal to math dot absolute value of my dividend. I don't want it to be a negative value or a positive value, then it would not work for the algorithm. BS, and it would be math dot abs of my divisor. Done. And I need to pass this abs value and not the normal value. Again, coming back to why we need to edit this is because we have these conditions. So first we need to check if our dividend, not the absolute one, the one that we have, is less than 0, and also we need to check if our divisor is less than 0. If so, what we need to do is we need to return result. Otherwise, what we need to do is we need to return negative of this result. I'll let you know why. If 10 and 3 both are negative, this happens, we need to return the result, which is plus 3. I'll edit it in a way that it works while for the language. It's easier for us to understand, but let's just do this. Again, if both of them are negative, this will return a true, which will return in result. If both of them are positive, this will return in a true, because this will return false, this will also return false, and we have our result. If any one of them is false, this will return in false. It works like an XOR. If this will return false, not XOR, it works like an something. I'm not sure if AND or OR, but you get the point. Since we are done with this negative positive thing, let's create a function. I'll call it public int get count. I have an integer dividend there, followed by an integer divisor. Okay, now what I want to do is I want an integer count. I'll initiate it by 0. Then what I'll do is I'll return this count. Then I'll think of the logic in between. Okay, now about the logic part. Do you remember what we did is we first check if the dividend minus divisor is greater than or equal to 0 or not. If it is, I'll create another variable. I'll call it step. I'll mark it 1 because we can take one divisor away from that dividend. Then what I'll do is I'll create a temp variable. I'll name it current equals to my dividend, because I don't divisor, sorry, because I don't my divisor being changed every time, because I don't want, because then I have to store its value, because I'll be manipulating it soon. Then what I'll do is I'll check if my dividend is large enough so that we can take away twice this divisor that we have here. If so, then what I want is I want this divisor to be updated. So this divisor becomes divisor plus divisor, and my step becomes my step plus my step. So I want my step to increment like 1 2 3 1 2 4 8 and so on, and this will do that. Again, if we are not in this condition, what I want is I want to decrement my dividend like we did. We decremented 10 to 4, we took away 6 from it. So what this should do is this should take away the current value from it, either it's 6 12 or whatever that is. Then what I want my count to be updated to my count plus my steps, number of steps that I have. At the end I'll return the count and I'll return the steps. And okay, so I'm so sorry, I forgot about this. It should be greater than 0, and let's see if it works or not. I hope it does. It works fine. Let's submit the code and see if it works or not. It works. So that's all for this video, guys. Thank you so much for watching.